Now next example, 6.11. What is the moment of inertia of the rod of mass capital M, length L, about an axis perpendicular to it through one end? So here we can use parallel axis theorem. See how? Suppose here we have a rod of mass M and length L, and we consider the moment of inertia of the rod with respect to the rotational axis passing through its center and perpendicular to the length. Then we already discussed in the table, it is ml square by 12. So here when we think about the rotational axis which is perpendicular to the length of the rod and passing through one end, it implies that, see, the thing is like this. Let's try to understand with the help of figure. So suppose this one is the rod. Okay. Now this is the rotational axis passing through the center, means it is the center of the mass. So we can write that is I, or we can say that is IC, and that is equal to ml square by 12. Now we want moment of inertia with respect to the axis which is perpendicular to length of the rod and it is passing through one end. So if we consider the axis passing through this end, so suppose moment of inertia, that is I dash. Now here perpendicular distance between these two axes, that is L by 2. So as per parallel axis theorem, we can write the moment of inertia with respect to this rotational axis equal to the summation of the moment of inertia of the parallel rotational axis passing through the center of mass and the product of mass of the body and square of the perpendicular distance between these two. So here perpendicular distance is L by 2. So now in this equation, if we substitute the values I, that is ml square by 12 plus m, now L by 2 whole square. So when you solve this one, you will get the answer ml square by 3. So in this way we can use parallel axis theorem. So in this way these theorems are very useful. Clear?